In autism, the prodrome for autism is mitochondrial insufficiency. And that's what leads to the gender bias, that 3 times more boys have autism versus girls.
The mitochondria, this is the part of the cell where the energy is produced or generated.
Correct. And so the mitochondria is one of your core components of your cellular health. It's very exactly that. We burn our energy. But it's also the core component that allows our body to deal with inflammation. So inflammation causes stress on the body and stress on the cellular machinery of your body. And when your mitochondrial capacity is weakened, you're not able to manage inflammation as much. And inflammation can then turn into what we call autoimmune disease from that point forward.
What does that look like in terms of the analysis that you're talking about? What does mitochondrial insufficiency look like?
So on a mass spectrometry perspective, what it basically says is, you're a closed system fundamentally, right? What comes in must come out. So if one part of your system is not working properly, okay, another part of your system has to pick up the slack, or things will get backed up. So what you can, it's basically like looking for traffic jams. So if all of a sudden 2 lanes of the freeway are blocked, okay, you don't have to actually go and measure the concrete where it's broken. You can pretty well determine where the breakdown is by looking where all the cars are. So cars get all backed up, and all of a sudden, people aren't idiots. They're not going to stay on the freeway forever. So sooner or later, people start taking side streets. And so all of a sudden, there's a whole bunch of cars on side streets that normally aren't on side streets. You're saying, well, why are there a whole bunch of cars over here? There's never any cars over here. And then you say, well, the reason we have this overactivity in these other areas is because there's a blockage in this area. And so using comprehensive biochemistry, you can then determine what parts of the human biochemical system are working less than proper capacity. And so in autism, it's that mitochondrial function. So when the mitochondrial function is impaired, if you put stress on a child that has an autistic prodrome, okay, then they aren't able to handle that. And it causes inflammation, it causes impaired myelination of the brain, and ultimately that creates this disrupted development of the child.
And with the plasmalogens being it sounds like the core of this approach to resolve autism. You mentioned before that there is all this vast research that's been done over the years into autism. So I take it the understanding that demyelination is a factor there has also been known for some time. What is distinct about the way your method of providing these plasmalogens that makes them particularly effective?
Well, see, these plasmalogens are kind of a unique set of molecules. They're not rare. 20-30% of your entire brain is plasmalogen. 50% of your heart membranes are plasmalogens. So we're dealing with a class of molecules that are in very high concentrations. So the human body is built of cells and membranes and structure. Plasmalogens are a critical building block. And in fact, it's so critical that we get very little from our diet, almost none. So we get a little bit from, obviously we get it from the placenta, from our mom while we're in utero, and then we get some of it from breast milk during early breastfeeding. And that gives us time to get our own endogenous plasmalogen manufacturing up to speed, okay? And of course, as humans, we're gonna have a big distribution, right? We're gonna have some people that can make lots of plasmalogens. There's gonna be some people who can't make very much plasmalogens. And then you combine that with the environment around them. The plasmalogen precursors, fact is that they just weren't available in our food supply at all because our body typically makes a lot of them. And if we eat plasmalogens from a food, like a nice juicy steak or something, they get digested in our stomach before they get absorbed because they're also involved in resolving inflammation. So they're very acid sensitive. So I designed molecules that are biologically available based upon the structure that's in human breast milk. In fact, the omega-9 plasmalogens, which are ones we use for myelination and for autism, they are the exact same molecules that are in human breast milk.